we have different types of gear materials that we select for the manufacturing of our gears. So the gear materials are available in three different types of grade materials defined by three agencies all around the world. The first agency is American Iron and Steel Institute. Then second agency is your Society of Automotive Engineers. So you know that this particular component is very much used in automobiles. So the Society of Automotive Engineers have set up their standards and specified their grades and categories for different materials to be used for formation of product. Then we have Japanese industrial standards, and most of the grades available in standard are also available in the same specification in the other standard with some other designation. So you can adopt the grade and designation as per the requirement of your company. Some company uses this SAE automotive grade material, some using the ASI automotive grade material, some companies using the Japanese industrial standard. So there should not be any problem and there should not be any confusion. So this table gives you recommended steels for various application and the gear types. So if you see here that the industrial application is your differentials to be used in automotive and heavy truck. So you have hypoids or hypocycloids design, you have spiral and straight bevel gears, and these are the recommended material choice. Out of this 4140 material is very common material. And similarly for drives in industrial tractor accessories, we have different types of gear design. You can refer it from this table. And heavy trucks, cross axle, helical spur, worms, they are manufactured by this different material. So if you search the material on the internet, you will find its nominal composition. So in most of the cases, the carbon steel, there are two types of materials are used for automotive application. One is the plain carbon steel and other is the alloy steel. So in plain carbon, the carbon percentage ranges from 0.15 to, and in alloy steels, chromium is added, molybdenum is added, and then you have different materials, different elements like molybdenum, nickel, chromium is used to give the required properties. Hardened steels which are hardened from your case to the depth, and there are some carburized steel which are hardened only on the surface. So we have different types of material for through hardened steels. These steels like 1040, 1060, 4140, 4034 steels are very much popular in the industries, and they are easily hardened using the induction heating process. And whenever you have some application area where you require carburized steels, so these grades like 1018, 4023, 20, 9310, these grades are very much popular in the. So these are the different types of gear materials which you can use to manufacture the gears as per your requirement. So we have basic four types of. So we have the form milling. We have first one is your form milling. Second one is your gear hobbing. Third one is your gear shaping, and third one is your gear broaching. So let's start with the first process, which is your form milling. So I think this process you might have seen, or if you remember that you have done it in your production lab in the fittings, you have formed the teeth with the help of a milling. So in this process, the machining operation is classified as forming because the shape of the cutter determines the geometry of the gear teeth. So whatever be the form which is present on the of your this cutter, it gives the same shape on the gear surface. What the advantage is that this process is very, the tooling required is very, however the production rates are very slow because each toothpaste is created one at a time and the gear blank must be indexed. So manually you have to perform the indexing. If you might have remembered the process of indexing, that how the indexing is done with the help of indexing plates. If you don't remember now, then you can search your books and also internet. There are different tutorials and very easy tutorials are available that how you can use the indexing plates. Another advantage of milling over gear hobbing is that this milling cutter is very less expensive. So this is the form milling operation. Then we have, after we have a gear hobbing. So gear hobbing operation is similar to the milling operation, but the cutter is somewhat complex and it is a series of the stacked cutters. You can see there are many cutters which are joined together and this particular tool is called Hob tool. So Hob tool is much more complex tool, and therefore it is more expensive than a form milling operation. So for this purpose, you require special machine which is called hobbing machine, and it takes care of the relative motion between the hob and your workpiece, and it regulates the relative speeds and feed motion between the hob cutter and your gear blank. So in this case, if you see that this is your gear blank, which is rotated at its own axis, then it can be given the work feed, and then at the top of it there is a hob tool which is rotated, and it has several cutting edges. So here automatic indexing is done with the help of this machine, and you can say this linear feed is also given to the gear blank throughout the thickness in order to achieve the required depth of the so several teeth are cut simultaneously in hobbing, which allows for the higher production rates than the form milling. So in the form milling, you have seen that we can cut one gear at a time, but here in this case you can see many gears or many teeth are cut simultaneously because of the number of multiple cutting edges. Then after this we have a gear. So in gear shaping operation, you have a reciprocating cutting tool. So this is a cutting tool which is given this reciprocating motion and also this rotary motion, and this is also given this indexing motion. So here the cutter has the general shape of the gear with cutting teeth on one side. So these edges, if you can see in this real picture, that there is a cutter teeth. This is a cutter which is given the up and down reciprocating motion, and your job is given the indexing, or times this cutter is also given the indexing. So basically in this case both the cutter and your blank is given the indexing, and gradually the material is removed from the surface and the teeth are formed onto the gear blank. So this is a very brief discussion about the gear shaping operation, and then you can find different types of video available on the internet. I'm also going to upload some of the videos in my Google Classroom. You can access them. We have the broaching option. So we have a broach tool here, and it is a cylindrical tool. If you see, this is a cylindrical tools, and many sharp cutting edges are basically present on this gear broach. Most preferably it is used to make the internal teeth, and it involves the shorter production cycle time and high tooling cost due to this broach, but it is recommended for higher volume, and the other benefit is that you get good dimensional accuracy. So here if you see the cross section of the tool consists of a series of gear shaped cutting tooth of increasing size to form this is somewhat given a taper. Initially it is given a small clearance so that it can easily pass out to the bore which is present at the center of your gear. Then slowly it is pulled out from the center, and then with the shearing operation and with the cutting it forms the teeth onto the over the circumference of the hole which is present at the. So this is a gear broaching operation, and this can be applied for both external gears and internal, but it is most preferred to form the internal. The last process is basically your gear shaving. So this is gear operation. It involves the use of a gear shape cutter. So you see in our previous slide there was a gear cutter which is having a solid single cutting edge, but here in this case you can see this is a gear shape cutter which has meshed, and this is meshed teeth, and it and more this cutting. So it is meshed with your finished, you can say the finished gear, and it is also given the reciprocating motion and also the rotary motion. So slowly these sharp cutting edges work like a razor which removes the burrs which are present onto the periphery or edges of these gears, so that it moves all the unwanted material, and it helps you to attain the required surface finish in your gears. So here small chips are material is removed in the form of small chips, and gear and slowly your gear achieves the required surface roughness. If you like then please subscribe to my, share it with your, and don't forget to hit the bell icon for the latest updates. Thanks for watching my videos.